Today we got a problem: design circular queue. Design your implementation of the circular queue. The circular queue is linear data structure. FIFO last is connected to first ring buffer. Okay. So initialize with size k, front, rear, enqueue, dequeue, circular or not. Okay, that's what's CPP, and then without the built-in queue data structure. That's okay. So I guess we just do pre-allocate vector and key pointers. Let's call it queue resize k, or rather assign k. What are we adding? Enqueue ints to -1. So what are the int values? Okay, so they are non-negative, and we will have, okay, int start rear is this. So what do we want to do? Enqueue. So if queue at rear is -1, don't equal -1, then we do else queue rear value rear +1 percentage k is k. Okay, now if you want dequeue, if queue rear otherwise so there is some element, right? So what we want to do is queue front is -1, then we want to do front +1 percentage. Wait, so if front is rear +1 percentage k, and then front +1 percentage k, what it means that this is an edge case where we have one element, and then I guess we don't have to move, so we have to, when we, in that case we could just return, but we can like move the pointers, so I guess we can. So basically we just do this, I guess, I think. Okay, front return queue front, return queue rear empty, return front rear and queue front -1 is full. That's interesting. Return rear +1 percentage k is front. Okay. Okay, so k is not initialized, so this k is that. Okay, that worked pretty good. So print and then we have dq, which is print, and then here is empty, is full. Boom. Let's see. So so first I enq1, then I enq2, then I enq3, then I enq4. It's true, 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 false, right? Then I get rear, which should be wait. So rear should be -1 first. What if they ask for rear first? So first, if so rear is empty, let's point to something. So int this sucks. Int new rear equals, now what? Front rear and rear front -1. There should be a negation sign in front of that. Else okay, that works. I guess there was just an indexing problem, because essentially what that meant is that I started pointing rear at 0, and when I insert element, then I would move rear, but the rear should point to last set element. So let's see. Okay, passes all edge cases. Let's see if I start with -1. And just do this. Yeah, that won't work, so let's get back to this. Boom, 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 boom. Okay. Should be fair enough. I mean, realistically, I could do like a linked list, but whatever. So simple pointers. Let's use a fixed size vector to represent the queue and keep pointers to front and rear of the queue. Approach. When inserting a new element, check if there is free place after rear in the queue. If not, and move the rear pointer. When removing an element, check if the queue when removing an element, check if there is any element at the front. If not, return false, else set the value at front to -1 and move the front pointer only if there was more than one element before, in order for front rear to hold. Okay, other methods are front and rear methods just access the respective elements using respective pointers. To check if the queue is empty, we check if there is no value at front and rear are at points to the same position. To check if the queue is full, we check if rear +1 front holds. O of 1 per operation, since they are all constant time, since we pre-allocated the queue in constructor. Space complexity is okay, where k is the size of the queue. Okay, a little boring, but whatever. Okay, see you tomorrow.